Welcome to this explainer. Right now, every time you fire a GET request with a massive query string stuffed into the URL, you're operating inside a design tension that has existed since the earliest days of HTTP. GET is safe. GET is cacheable, but GET cannot carry a body, and that limitation has quietly shaped how we build APIs for decades. Until now. RFC 1008 introduces a brand new HTTP method called query, and it fundamentally changes this equation. Let's kick things off with Section 1, the GET limitation problem. RFC 1008 identifies four specific issues with using GET for complex queries. First, size limits. A request passes through many uncoordinated systems, proxies, load balancers, CDNs, and the HTTP specification recommends supporting at least 8,000 octets. But here's the thing, you often don't know the actual limit until you hit it. Second, encoding overhead. Expressing structured data like JSON filters inside a URI requires percent encoding. It's inefficient and bloated. Third, URIs get logged everywhere. Your query parameters end up in server logs, proxy logs, even browser history and bookmarks. And fourth, and this one is subtle, encoding queries directly into the URI effectively casts every possible combination of query inputs as a distinct resource. That breaks the fundamental REST model. Moving into Section 2, why developers reach for POST. Since GET can't carry a body, the practical workaround has been simple. Use POST. You send a post to /feed with a content type of application, /xww form URL encoded. And your query parameters go in the request body instead of the URL. Problem solved, right? Well, not exactly. Because here's the catch. POST is not inherently safe. POST is not guaranteed to be idempotent. When a proxy or a client sees a POST request, it has no way to know, without specific knowledge of that exact server. Whether this is a harmless search query or a request that creates a new resource, processes a payment, or modifies state, that ambiguity means caches cannot touch it. Retries are dangerous. The entire HTTP infrastructure treats it as a potential state-changing operation. Which brings us to Section 3, the query method itself. RFC 1008 defines query as a means of making a safe, idempotent request that encloses a representation describing how the request is to be processed by the target resource. In plain terms, query does what POST does for search-type operations, but with explicit guarantees baked into the method itself. The request looks almost identical to the POST version. Same target URI, same content type, same body containing your query parameters. But the method line reads query instead of POST. That single word change tells every intermediary, every proxy, every cache, every load balancer, this operation is safe. You can cache it, you can retry it. It will not change state on the server, and just like that, the ambiguity disappears. Section 4. Let's get precise about what safe and idempotent actually mean, because these terms come straight from the HTTP specification. According to RFC 1008, query requests are safe with regard to the target resource. That means the client does not request or expect any change to the state of the target resource. The server is not supposed to modify data as a side effect of the query. Now, idempotent goes a step further. It means the request can be retried or repeated when needed. After a connection failure, after a timeout, you can send the exact same query request again, and the result will be the same. No partial state changes, no duplicate side effects. This is the guarantee that POST simply cannot make. And this is why the HTTP infrastructure can suddenly treat query differently. Let that sink in. A single method change, and caching, retries, and content negotiation all become available where they weren't before. Moving into Section 5, the request body and content type. Here's where query borrows from POST's playbook. The content of the request and its media type define the query. The origin server determines the scope of the operation based on the target resource. Critically, the RFC states that servers must fail the request if the content type header is missing or inconsistent with the request content. There is no guessing, no content sniffing. You declare what you're sending, and the server